Hello, today we will learn about conditional statements. First, let's learn about the bold type before learning about conditional statements. The bold type is a type that has only two values, true and false. Try typing type true in the Python shell. When type true is entered, class bool is printed as shown. Same happens for type false. However, in Python, lowercase true and false are not treated as bool types. So when you want to use a bool value, the first letter of the value must be capitalized. A Boolean expression is an expression that evaluates to a Boolean value. For example, 1 is greater than 2 evaluates to false in Python. There are other operators that return Boolean values. You can see them in the table. X equals y becomes true if the two values x and y have the same value, and becomes false if they're different. Conversely, x exclamation equals y is true if the two values x, y are different, and x exclamation equals y is false if they're the same. The four operators below have similar meanings to the inequality signs used in mathematics. The first operator returns true if x is greater than y, and returns false otherwise. The second operator returns true if x is less than y. The third operator returns true if x is greater than or equal to y and returns false otherwise. The last operator evaluates to true when x is less than or equal to y and evaluates to false otherwise. Enter the Boolean expression shown on the slide at the Python prompt. As you can see, all Boolean expressions are evaluated as Boolean values. You can see that true and true are printed, and you can see the type of last expression is also bold type. If you put 1 equals 1 in the 1 equals 1 variable, you can see that a bold type value of true is stored in 1 equals 1. Pause the video and try typing the code in the slides into the Python prompt to see what is printed on the screen. Do you get the same result as displayed on the slide? First, type true and type false will raise an error. This is because lowercase true and false are not values of type bool in Python. When the code x equals 3 is less than 2 is executed, the right value is calculated first. Therefore, the expression 3 is less than 2 on the right side of this assignment statement is evaluated first. If the computer evaluates this expression, then the expression becomes false, and false will be then stored in a variable called x. After that, if you print x, you can see that false is printed. If type x is entered in the prompt, you can see that class bool is printed. The code y equals 1 means storing 1 in the variable y. Therefore, if you write the expression y is less than 2, it becomes 1 is less than 2. So the value true appears on the shell. Conditional statements are statements that control the flow of program execution according to a given condition. The condition is usually a Boolean expression, and the conditional statement determines which code block to execute based on evaluation result of this condition. In Python, the keywords if, else, and elif are used to create conditional statements. If statement executes the code block under it only when the given condition evaluates to true. For example, if x is greater than 1, print x means if x is greater than 1, print x. If you want to use a conditional statement, add a space character after if, and write the condition, and then add a colon, change the line, and indent like we did to define a function. After that, write the code you want to run if the condition is satisfied. Code that is not indented will not be included in the conditional statement, and it'll be executed after the conditional statement ends. Let's assume we have an exam that requires a score of 70 or higher to pass. Let's write a script program that prints the string "you passed the exam" when the test score exceeds 70. First, create a file called exam.py. Write a program that receives an integer from the user, stores it in a variable called score, and prints "you passed the exam" on the screen if the value is 70 or higher. The user's input is string type, so don't forget to cast it into int. We can write the program as shown in the slide. First, receive the score from the user using the input function, and convert the return value of the input function into an int type. And we can assign this value to score variable. The condition in the if statement is score is 70 or higher. In the next line, you can see that the print function is called after the indentation. In this case, the print function will be executed only when the if condition is satisfied. If you run this program and type 70, it prints "you passed the exam." Currently, nothing is printed if the score is lower than 70. How can we print something when the score is lower than 70? In this case, you can use the if-else statement. An if-else statement is similar to an if statement, except that it executes another code when the condition is false. As you can see in the slide, the if-else statement can be made in the following format. The method of writing the if statement is the same, but when the condition of the if is false, write else colon and write the code block to be executed in the place of statement 2 when the condition of if is false. If we modify the code by adding else to the code we wrote earlier, it looks like this. Let's try to understand this code. The number input by the user is stored in the score. If the score is 70 or higher, "you passed the exam" is printed. Else, "you failed the exam" is printed. Else can be interpreted as a case of less than 70 points. For example, if you enter 80 as shown in the slide, "you passed the exam" will be printed. And if you enter 60, the program will print "you failed the exam" in the else code block. What if the exam has more than one subject? For example, let's say we have exams in 2 subjects, English and mathematics. Assume that you need a score of 70 in both subjects to pass. In this case, how can we change the program to print the test results? In this case, you can use logical operators. Logical operators help you create more complex conditions. Logical operators include and, or, and not. Let's learn these logical operators in detail. Let's start with AND operator. If A and B are values of type bool, the expression A and B becomes true only when value A is true and value B is true. You can check the evaluation result of the expression A and B according to the values of A and B in the table. As you can see, A and B evaluates to false except when both values are true. Here's an example case of using the AND operator. In math, if a number is in a certain range, we express it in the form A is less than B is less than C. So what if we want to express the condition that the variable y is greater than 1 and less than 3 in Python language? Unfortunately, unlike in math, you can't write expressions like 1 is less than y is less than 3 in Python. Instead, we can divide it into 2 expressions. Then you can use the AND operator as shown in the slide to express the condition. AND operator allows us to create a conditional expression that considers multiple conditions. If you look closely, you can see that the way of expressing conditions in Python language is similar to how humans express certain conditions verbally. For example, we read 1 is less than y is less than 3 as the variable y is greater than 1 and less than 3. Next, let's look at the OR operator. When A and B are values of type bool, the expression A or B becomes true when A is true or B is true. You can check the evaluation result of the expression A or B according to the values of A and B in the table. As you can see, A or B evaluates to true except when both values are false. Finally, let's look at the NOT operator. The NOT operator reverses a Boolean value. For example, not true becomes false and not false becomes true. If multiple logical operators are used in an expression, in what order should they be evaluated? For logical operators, the order of operations is not, and, or. It is convenient if you think that not should be calculated first. For example, for the expression A or not B and C, first, not B is evaluated, then not B and C is evaluated, and finally, A or not B and C is evaluated. The operation is performed in the same order as the expression, as you can see in the slide. However, it is recommended to use parentheses to make the code easier to understand. Now, let's complete the program we were trying to implement earlier. First, try to get a score from the user into two variables, English score and math score. Then, using logical operators and conditional statements, write a program that prints "you passed the exam" if both subjects score 70 or higher, else prints "you failed the exam." Pause the video and continue playing the lecture after trying to write the code yourself. Did you write the code similar to the one on the slide? If you look at the slide, you can see that I wrote the program using the logical operator AND. First, the program receives and saves English score and math score from the user. And then, "you passed the exam" is printed if both English score and math score are 70 or higher. Otherwise, else, "you failed the exam" is printed. If you run the program and input various values, you can check that the program is implemented correctly. For example, if an English score of 90 points and a math score of 80 points are entered, the string "you passed the exam" is printed. However, if the score of one of the two subjects is 50 or both scores are less than 70, the string "you failed the exam" is printed. So far, we have implemented a program that determines if the student has passed or failed an exam. Now, let's evaluate students' grades in a different way. Let's create a program that prints excellent, good, and needs improvement according to students' grades. When the user inputs scores of English and math, if both scores are 80 or higher, then print excellent. Print good if one of English or math scores is 80 or more. Print needs improvement if both scores are less than 80. Using what you've learned so far, you'll be able to write the program that is similar to the code shown in the slide. In the first conditional statement, it checks whether both exam scores are 80 or higher. In that case, the program prints excellent. And in the second conditional statement, if one of English or math exam scores exceeds 80 points, good is printed. In other cases, it prints needs improvement. But there is one problem with this code. Let's assume that you have a score of 80 or higher in both mathematics and English. If both subjects scores more than 80, the condition of the first if statement becomes true and excellent is printed. But the condition of the second if statement also becomes true and good is also printed on the screen. You can use the keyword elif to solve this problem. The elif keyword is used with the if statement and can be used to express various conditions other than if. Elif is short for else if, which executes the block of code below elif if the condition of the preceding if is false and the condition of the elif is true. To explain again using the slide, if condition 1 is true, only statement 1 is executed. But if condition 1 is false and condition 2 is true, only statement 2 is executed. If both condition 1 and 2 are false, statement 3 under the else keyword is executed. The flow of execution of if, elif, else statement can be understood more easily by looking at this slide. Let's use elif to modify the program we made earlier. As shown in the slide, if you change the second if to elif, if both English and math scores are 80 or higher, only the part below the first if statement is executed, and the rest are not executed. If or else keyword can be used only once in one conditional statement, but more than one elif can be used in one conditional statement. Elif can be used multiple times when many different conditions exist and different code needs to be executed for each condition. When multiple elifs are used, the Python interpreter checks the conditional statement from the top, from the if keyword. Therefore, an elif statement is executed only when all the preceding conditions are false and the condition of the corresponding elif is true. For example, statement n is executed only if condition n is shown in the slide is true and condition 1 through condition n-1 are all false. When we use the if-elif clause, else is not forced to be used. For example, if you want to perform an operation only under certain conditions, write those conditions in if and elif statements. In other cases, the program exits the conditional statement and continues without performing any other else operation. Let's modify the program we wrote earlier. When a user incorrectly enters a score as a negative number or a value greater than 100, we want to print "score is out of range, please try again," and make the program terminate. The previous program can be modified as follows. First, the numbers entered by the user are checked in the first if statement. As shown in the slide, we can use the OR operator. If the score of either subject is less than 0 or greater than 100, "score is out of range, please try again" is printed. An elif is used to check whether both subjects have 80 points or more, and the rest is the same as before. Another conditional statement can be written in the code block inside the conditional statement. For example, you can write another conditional statement inside a code block of else conditional statement. Let me explain the code on the slide. If condition 1 is true, statement 1 is executed. In other cases, if condition 2 is true, statement 2 is executed. If condition 2 is false, statement 3 is executed. In this way, you can write conditional statements inside conditional statements. Conditional statements can be written not only in else, but also in if and elif conditions. Let's use this nested conditional statement to modify the code we've written so far. Let's change the second elif statement in the code on the slide. Let's create a program that prints good if the score in only one subject among English and math is 80 or higher, and then prints comments for the subject that does not exceed 80. If the English score is less than 80, print "English needs improvement," the line after good. If the math score is less than 80, print "Math needs improvement" on the line after good. Write the code using nested conditional statements. For example, we can change the code from the previous slide to print good like before. If the English score is less than 80, print "English needs improvement." Else, prints "Math needs improvement." Run the program and enter 60 points for English and 100 points for math. When the English score is 60 and the math score is 100, good is printed and "English needs improvement" is printed. On the other hand, if you input 90 points in English and 50 points in math, good is printed and "Math needs improvement" is printed. Now, let's solve the exercise problem. Enter the code from the slide line by line into Python prompt and predict what the result will be. Second, let's write a program that displays the level of danger according to the noise level. We want to create a program that receives the noise intensity in decibels from the user and display the level of danger of the noise. The decibel value entered by the user is a natural number, and the degree of danger according to the decibel values is shown in the slide. Write a program that when the user inputs a certain decibel value, it displays the level of danger of that decibel value on the screen as the string shown on the slide. Let's solve the first exercise. First, x becomes true. Y will also be true. Z will be false. The last code is not x or y and z. So first, not x is evaluated, then and is evaluated, and finally or is evaluated. Not x is false. Y and z is false. So not x or y and z is equivalent to not x or y and z. When this expression is evaluated, it becomes false or false. Finally, the expression evaluates to false. Here's an example solution for the second question. First, the program receives the noise value from the user, converts it to an int type, and stores it in a variable called noiseInt. If the user inputs a negative number, we can print the string, please input a positive integer. If the input value is less than 80 without being negative, no risk is printed. And if the above two conditions are not true and the noise value is less than 90, it means that the noise value is greater than or equal to 80 and less than 90. Thus, the string harmfulness threshold is printed for this case. And when the noise level is between 90 and 120, the code block below the last elif statement is executed, and danger, harmful sounds is printed. Else, the noise intensity exceeds 120, so we can print the string irreversible damage. And if we enter various values as shown in the slide, we can confirm that the program works correctly. Thank you for watching today's lecture. Next class, we will learn about iterations.